So let's see. What's this first one? First one is 10 to the 6 divided by 10 to the 4, which is 10 to the 6 minus 4 is 10 squared. Everybody okay with that? So we have 2 to the power of 8. This is 2 to the power of 1. So that's 2 to the 8 divided by 2 to the 1, which is 2 to the 8 minus 1, which is 2 to the 7. Pretty simple. We know anything to the power of 0 is 1. Anything to the power of 0 is 1. This will end up being 1, so that will be 3 times 1, which is 3. This will simply just be 1 all over 10 to the power of 3, and that's all I really wanted to see. If you want, you could have put 1 over 1,000, that's fine, but that is the answer I wanted. This is really 1 over 8 to the power of 1, which is simply 1 over 8. Right? This one here, we are talking about 1 over 3 cubed, and if I go in pretty fast, just please let me know. Alright, you could have put 3 3s and 9 3s are 27. You could have put I saw a couple of you all went this extra step, which is good, but I just really wanted this one. I just wanted to see that you know your laws of indices. Anything to the power of a half is actually the square root of 49. Right? Now at the end of the day, we have this this rule which says that a to the power of x over y, the denominator is the root and the numerator is the power, and we proved this in the last class. So a way to just make a note that we have here 49 to the power of 1 over 2. So the denominator is the root, which is the square root in this case, of 49, and the numerator to the power of 1. So you could see here that the rule that you are using, you probably don't even know the rule that you're using, you know? So in this case here, the denominator is the cube root of 8 squared, the numerator. In this case, the denominator is the square root of 25 to the power of 3. And just stop me or slow me down if I go in too fast. In this case, the denominator is 5, so we have the 5th root of 32 to the power of 3. In this case, the rule says you have to multiply, so that's 2 to the 3 times 2, which is 2, 3 2s are 6, right? And in this case, we have 3 to the power of 4 multiplied by a quarter, which is 3 to the power of 1, which is 3. Right? So I think everybody should be okay with that. Anybody have any questions about this first set? Okay, Caitlin, you alright?
Yeah.
Okay. Multiply, so you just add the indices. So that'll be m to the 5 plus 3, which is m to the 8, right? This is to the power of 1, so that's x to the 1 plus 2, which is x cubed, right? This here is x to the 4 plus 2, 4, 5, 6, x to the power of 6. This is a b over here, and I hope that was a little bit clearer on your paper. It's only because of how I zoomed in here, it's looking so blurry. But y squared multiplied by y to the power of b, right? And there's nothing I could do there, but I could join them, y to the power of 2 plus b, right? You add your indices when you're multiplying. So that's all you could basically do with that one. This one here is just your simple laws of indices, a to the power of m plus n, right? Number 20, this is your dividend, so you minus your indices, x to the power of 9 minus 2, which is x to the 7. Same thing here, t to the 4 minus 2, which is t squared. Over here, you minus your indices. So that's x to the power of 7 minus the other indice, which is negative 2. Which is, you minus a minus. That becomes a plus. 7, 8, 9. X to the power of 9. Of course, anything to the power of 0 is 1. Anything to the power of 0 is 1. This will end up being 1, so you have a multiplied by 1, which is just a. This will end up being 1, so I'll have x plus 1, and you know there's nothing I could do with that, so that's the answer. That just stays right there. Over here, you just multiply your 4 times 3, so x to the power of 3 times 4. 4 3s are 12, x to the 12. In this case, you have to multiply this 4 by all of the indices. So you're multiplying the 4 by the 2, and you're multiplying the 4 by the 4. So the 4 by the 2 will give me a to the power of 8. 4 2s are 8. And the 4 by the 4, 4 4 is 16, b to the power of 16. Okay. Same thing over here, you multiply this negative 1 by negative 1. You also multiply the negative 1 by the 5. So I have p, negative 1 times negative 1 is positive 1, and then q to the negative 5. So it's p q to the power of negative 5. And in a situation like this, please make note that it is only the q that is to the power of negative 5. Some people will think it's the p as well, but no, it's not the p. The p is to the power of 1. The only way it would have been both is if you had these brackets here. But guess what? We don't. So it's only that q is to the power of 5. So don't get that mixed up, please. Right? And of course, this is a, and I wrote that like a 9, sorry. This is a to the power of a half multiplied by 3, which is a to the power of 3 on 2, which is the answer. You could have stick with this. You could have go the extra step to say it's the square root of a cubed. Yes. So out of that first 30, did anybody get any wrong?
Yes, sir.
Alright, which ones you got wrong?
Number 28 and 20.
28 and 29. You didn't know that you had to multiply by all of the indices in there.
Honestly, I'm not sure. Oh wait, no, see how I'm making this.
You see? Where you did?
Basically, fill the brackets with a squared and b to the power of 4. I add the two powers, and then I get a b to the power of 6, and I multiply a b to the power of 6 by
Right. So you had a squared b to the 4, and the first thing you do is you add them because you're multiplying a times b, right? So yeah, a to the power of 6. But remember, you cannot do this. Yeah, you cannot add the indices here. You could only add the indices if it was the same number and the same base. And that is an important thing with all of these laws of indices questions, is that you had to have the same base. You get what I'm saying? So at the end of the day, once you see a A over here and a B over here, there's nothing you could do inside of it. Right? So just be careful with that. But this I love how we when we get these things wrong. And I could imagine some of the juicy mistakes that we are going to make. You know, fine, look at that very important lesson that you learned from making that mistake. Yeah? So it's wonderful when we make mistakes like that. Right? Caitlin, you got any wrong? Which one?
I don't think that's and
You understand why?
yeah.
Okay. I'm curious as to what your did wrong for number 30, but I know you can't talk much, so don't study it, right? Scotia, you got any wrong? Number 30?
Yeah.
What will they do for number 30?
The square root of 2 and the a to the power of 1 with the brackets and the 3 outside.
You put the square root of a and the brackets with the 3 outside. Right. So what that is, I mean, that is correct, but you just basically wrote over this, because that is the square root of 2 there. So you have the square root of a, brackets with the 3 outside, eh?
Yeah.
But the square root of a could be written as a to the half, eh? Brackets with the 3 outside, eh? So that means that I could multiply a to the 3 on 2, and then I could use my law to say a cubed the square root. So watch how that does work. Watch how that does work. That from the laws of indices, I went from this to this, and saying that they're both the same. That's kind of cool, right? That if you had the, you know, in that case and in this case, if you had the indices, you know. So they are the same, but really and truly what you did here is you just wrote over the question. You understand?
Yeah.
Alright. So let's move on. Now, how was these questions here for you guys? Because I know we did a couple of these last week, so you kind of saw what was required. Shazay, how you tackled these 20 over here?
Well, I do them.
That's I really appreciate that you did do them, right? So in this one here, number 31, there's a law of indices that tells me that this is 1 to the power of negative 1 all over x to the power of negative 1. So that's one law of indices that I use there to get from here to here. Alright, Shazay, I think your mic on. Right? Now 1 to the power of negative 1 is just simply 1. 1 to any power is just 1. All over x to the negative 1. And now we're going to use a second law of indices. The law of indices is a to the m is equal to 1 over a. No, a to the negative m is 1 over a to the m. Where when you have a fraction, you take this index and you put a negative sign in front of it. Yeah. So what I'll do is I will take this index, which is negative 1, and I'll put a negative sign in front of it, which means that that is x to the power of 1, which is just x. So how you guys, anybody got this wrong?
Yes.
You do. Why? What did you all do? You all understood what I did here?
Yeah.
You all understand the laws that I used? Shazay, how about you?
Yes, sir.
Right? The first law I used was the fraction over m is equal to a to the m over b to the m. And Shazay, you had asked the question last week, how do you know which law to use? Well, I just look at the question and I say, you know what? This looks like this, so I could use that. So I could say 1 to the negative 1 all over x to the negative 1. And then I say, well, hey, this looks like another law, because that is just 1 over x to the negative 1. Right? So it looks like this law, 1 over a to the m. It looks like this law. So hence I will get x to the negative 1, which is x to the 1. Scotia, what did you do wrong here? Sorry, I'm not hearing you properly.
I don't know what to do.
You didn't really know what to do? So you didn't do it?
I mean, I tried something, but I know it was wrong. So.
But you see how it's just by how the question looking, and I just thinking about, well, what law does that look like? Yeah. So that's all that it is. Like, this only looks like one law. That is 1 over y cubed. I can't do nothing else with that. But this looks like a law when I see that negative sign over there. Right? So it's just how it's looking. Right? So these guys are pretty easy. We have 2 to the n plus 2n plus 3n. So 3 and 2 is 5 and 1 is 6. 2 to the 6n. Anybody got this one wrong? Okay. We have a to the 3 plus 5 plus negative 2. 5 and 3 is 8. So that's a to the 8 minus 2, which is a to the 6. Anybody got this wrong? Okay. x2 plus 4 plus 3. 4 and 2 is 6. 7, 8, 9. X to the power of 9. Right? So in this case, and I should say, I'm suspecting that you would have made the same error in these two as well. Right? Right? Where you actually have to multiply this 4 by the 2. And you can't multiply as two different bases. But you have to remember that this q is actually to the power of 1. So you have to multiply the 4 by that 1. Right? So you understand this, Shizzy?
Yes, sir.
Right? I'm sure you'll never make this mistake again. 4 times 2, that is p to the power of 8. 4 2s are 8. And then 4 times 1, that is q to the power of 1. And then you're multiplying that by 5 2s are 10, q to the power of 10, and 5 1s. This is p, so that's p to the power of 5. Now this is multiplication, and multiplication is commutative. It doesn't matter the order. So I could put the p's together, p to the 8 times p to the 5, and then multiply by the q's together, q to the 1 times q to the 10. Is it q to the 1 or is it q to the 1? Yes, it should be a 4. Thank you very much. I was wondering where that 1 came from. I hope I didn't confuse anybody with that. If anybody's confused, just say so, right? So obviously I can just add my p's now, and I can add my q's now. So it'll be p to the power of 8 plus 5, and that being multiplied by q to the power of 4 plus 10. So 5 and 8 is what? 8, 9, 10, 11, 12, 13. So that's p to the power of 13 times q to the power of 14. So see how you feel about this one.
Yeah, I understand now.
You understand it, right? Did you get it right, or did you make the same mistake?
No, I made the same mistake for 36 and 37, I guess.
Right, okay. And what about you, Scotia? Are you okay with this one? And Caitlin, did you get this one right?
Yeah.
Lovely, lovely. I'm glad to hear that. So we have here now this A and this B is two different numbers, so I can't really do nothing with the indices. So I'll just be left with A cubed B to the minus 2. Nothing I could do with that. That being multiplied by this, and I could times this. 4 times 2 is 8. A to the 8. 4 times 2 is 8. B to the 8. Right? So therefore, I have now, because everything is being multiplied right through, have no addition or subtraction. It's just multiplication right through. This A times this B times this A times this B means that I can literally group the A's and the B's just like we did before in this question over here. So I can literally see that is A to the 8 plus 3, 8, 9, 10, 11, multiplied by B to the negative 2 plus 8, which is 8 minus 2, which is 6. So say how you feel about this one.
Yeah, I understand.
You understand, right? Caitlin and Scotia, you all okay? Rewrite the following expressions using only positive indices. So we know that this here boils down to 1, and that 1 is being multiplied. Well, it doesn't matter what the 1 is being multiplied by because it will just be itself. So this is a to the power of a half times 4, because this 4 is being multiplied by a half. So that is, well, this 1 gone, forget about that 1. That is a to the power of 4 over 2, so the answer is a squared. Scotia, you got this one?
No.
No? What did you do?
Same thing from last time.
I don't understand. What?
Had the story to say in the brackets with 4.
Ah, with the 4 outside the bracket, right? Yeah, but you understand. You just rewrite the question, right? But did you at least put this as 1?
Yeah.
Right. So basically, your answer is the square root of a4, right? That was your answer, and this is the square root of a4, as we learned in the last one, that they are the same thing, which is kind of cool, right? Shazay, you understand how I did that one?
Yeah, I got that one.
Alright, lovely. So we have this here. I want to ask Caitlin too, but I know she can't talk. So, Caitlin, who win the Spotlight Challenge last week? Did we have a Spotlight Challenge last week? No? Okay. Right. So we have this one here. Over x to the 3 over x cubed. Now remember, when you have a brackets, this x is to the power of 1. But guess what? This 2 is also to the power of 1. So this negative 3 is being multiplied by this power and is being multiplied by that power. So now I will have negative 3 times 1, which is 2 to the power of negative 3. And then negative 3 times 1 is x to the power of negative 3. And that is being divided by x cubed. And remember, I could pull out the 2 if I wanted to. I could say this is 2 to the negative 3 over 1 and multiplied by x to the negative 3 all over x cubed. Now there are different ways to do it. You might not have done it the same way that I did, but that's okay. So I just get rid of this. I separate the 2 from it because I wanted to work on this. Right? So I can see that this is just 2 to the negative 3, and that is being multiplied by this is x to the negative 3 minus 3. Yeah, so you have to minus the indices. So the first indice is negative 3 and the second indice is 3, and I'm minusing that. So that is 2 to the negative 3 times minus 3 is x to the negative 6. So now I have 2 to the negative 3 x to the negative 6. Yeah. Now, if I want, I could simplify this further. Did anybody reach here? No. No, why not? What did you all do wrong so far? How did you guys approach this one?
Well, I didn't know that even though the power of 1 means you have to multiply it by whatever outside brackets. So it might be the same thing from before, and just do 2x by negative 3.
2x to the power of negative 3. So you just wrote 2x to the power of negative 3. Right?
Yeah.
But what this means is that the x is to the power of negative 3, and that your 2 is still to the power of 1. Yeah? So that yes, right? So that's good. These are the lovely mistakes that we like to make, right? So Caitlin, you understand how we got to this level?
Yeah.
Alright. Now we don't have to leave it like this. I could actually pull out, because negative 3 and negative 6 is kind of the same, you know. Negative 3 could go into both of it. So I can actually say 2 x to the negative 2. No. How about this? How about this? I could actually see that this is 2x squared to the power of negative 3. You all understand how I went from here to here?
No.
I basically recognized that, hey, negative 3, this 3, and this 6, they're factors. 6 is a multiple of 3, right? So basically I pull out negative 3. So if you look at it this way, negative 3 multiplied by this 1 will give me 2 to the negative 3. And then negative 3 multiplied by this 2 will give me 3 2s are x to the negative 6. You all see what I do there now?
Yeah.
Yes.
Yeah. So you can see here that I used that rule backwards now. So the rule that I used was, what it was? A to the m all to the power of n, a to the m times n. But I use it backwards. In this case, I had a to the m times n, and I decided to pull out the n and have a to the m all to the power of n. And I did it with 2 of them. And I'm glad that you all seeing that that this rule could be expanded, so I could have a to the p, and b to the q, and c to the r, all to the power of n. And this just means n is being multiplied by everything. So a to the power of pn, b to the power of qn, c to the power of rn. So it's the same rule, but it just shows that no matter how much different items you have inside the brackets, this outside power needs to be multiplied by everything in it. Right? Scotia, Shazay, y'all alright?
Yes, sir.
Alright. Caitlin, I'm trying to not call you, so so if you having any problems with anything or you don't understand anything, let me know one time, right? So here we go. I have now this, and I did this last week, so I hope that you guys remembered how to do it, right? I see here that I have 2a squared b to the negative 2 divided by 2 to the negative 3 b to the negative 4. Now initially I have to look at this and say, well, you know what, I can't multiply this a by this b over here, so nothing could go on in the numerator. I can't multiply the 2 by the b either, so nothing could go on in the denominator. I know at some point in time the b's will cancel, right? Them b's will cancel off, but the thing is that them b's negative now. So because the b's negative, I'm afraid to cancel them. I'm not sure if I'll do it correct. You know, I'm not sure if I'll do it correct. So what I'll do is I'll remember my arithmetic, and I will split up this fraction. So this fraction could be also written as, because everything here is being multiplied, and that is why I say, others always say, the biggest problem with algebra is actually arithmetic, right? So if you guys had really known your arithmetic, you would have known that because everything is being multiplied here, have no additions, no subtractions, means that I can actually pull out 2 over 2 to the negative 3, and that's being multiplied by a squared over 1, and that is being multiplied by b to the negative 2 all over b to the negative 4. Now I did this last week, but I just want to hear you guys, Scotia, Caitlin, and Shazay. Do you understand how I got from here to here? I hear from, I don't know who I hear from there. I hear one out of, that was Scotia. All right, what about you, Caitlin and Shizzy?
You could just keep one more time.
No problem. And how about you, Caitlin? You understand how I make that leap? Huh? No problem. All right. This basically came from the simple thing of adding fractions. Remember when you so not adding fractions, sorry, multiplying fractions. Algebra, not algebra, arithmetic, right? The normal arithmetic when you're multiplying fractions. If I have, and I'll just zoom back in here. If I was to have two fractions being multiplied, a over b times c over d. What do I do when you're multiplying fractions? You multiply your numerator to get ac, you multiply your denominator to get bd. So Shazay, Caitlin, you all cool with this, right?
Yes.
Right? But what if I was given AC over BD? Notice how everything is being multiplied there. So if I wanted to, I could split it up. I could say, well, all right, I could pull out the A. I could split this up in all different kind of ways, you know. I could say that this is A over 1 multiplied by C over BD. Yeah, I could split this up all kind of ways, right? Caitlin, Shazay, let's see how I get from here to here.
Yes, sir.
Right. I could also say that this is A over B multiplied by C over D, which is the original thing. But I could also say that this is AC over B multiplied by 1 over D. And all of these are true. Right? So when it comes to the multiplication of fractions, you could actually, because everything is being multiplied, you could actually change the order. Like in this case here, I could actually say that, you know what, because I have AC over BD, I could actually say that the C and the D, the C and the B being multiplied by the A over D. I could actually do it like this. Because when you do out this multiplication, you just end up getting back the same thing. So Caitlin and Shazay, you all okay with this in red here?
Yes, sir.
Alright. So that's all that I did. That is all that I did over here. Look at it. That's all that I did over here. Because 2 multiplied by a squared multiplied by that will give me 2a squared b to the negative 2. And then this 2 multiplied by 1 and that multiplied by that will give me 2b to the negative 4, which is that. You all seeing it now?
Yes, sir.
Yeah.
Right. So at the end of the day, when I looked at this and I see that there's not much to do in my numerator, not much to do in the denominator, I could cross off the b's though, but I'm not really too sure. I'm not really too sure how it'll cross off because it's negative numbers, it's confusing. Right? So what I decided to do, and remember there are many ways to do it, this is not the only way. Right? You could have, if you were smart enough, just cross off the b one time. But at the end of the day, I decided to split it up. I pull the actual numbers out, the 2's. I pull the 2's out because I could actually manipulate, use my laws of indices, because these are the same bases. The base is 2. Remember, this top 2 is actually 2 to the power of 1. So I separated it into like terms. This a squared by himself. Yeah, this a squared by himself. And then the b's, you know, I separated the b's there. So now I could work them separately. So I had one big complicated problem and I split it up into 3 simple problems. This is what critical thinking means. This is what maths is all about. Maths and critical thinking is all about taking big, hard problems and breaking them up into small, simple problems. So we could see here that this is going to be 2 to the power of 1 minus the negative 3. Yeah. And that's going to be multiplied by the a squared, which is nothing I could do with that. And that's going to be multiplied by b to the power of the negative 2 minus the negative 4. Be careful with your sign. Right? And watch how easy it is once you know your laws of indices to get there, right? So we have 2 to the power of 1 plus 3, because negative and a negative. So 1 plus 3 is 4, times a squared times, this is b to the negative 2. Negative 2 minus minus 4 is negative 2 plus 4, which is 4 minus 2, which is 2. So this is b squared. So now I have my answer being 2 to the 4 a squared b squared. You all understand how I reached there?
Yes.
Scotia, you okay?
Yeah.
Did you get this one?
I made a mistake by the T.
Yeah.
For the indices.
With the negative sign.
Yeah.
Yeah. You just put negative 2 minus 4.
Yeah.
Yeah, I thought that. Yeah. Remember, a to the m all over a to the n is a to the m minus n. So no matter what this index is, no matter what this index is, sorry, you'll have the minus between them. So that is why I put it in brackets. This is the first index, this is the second index, and I have my minus between them. Brackets is your friend, right? Always use brackets, right? But let me ask you all something. Can this here be simplified further using another law of indices? Aren't 2, 2, and 4 factors of each other? So if I pull the 2 out, what will I get? I'll get 2 squared AB all to the power of 2, eh?
Yeah.
She say that makes sense there? Yeah. So you're seeing there. And I could say 2 2s are 4, so that is 4AB all to the power of 2. And I think that is as simple as we could get it. We can't make it simpler than that. Do your teachers use Microsoft OneNote like this?
I don't think so. I see some of them use one word sound. I don't know what's in it.
I find this OneNote is the best.
Yeah.
Like
last week.
And the thing is, a lot of teachers have Microsoft Office and don't know that you have OneNote in Microsoft Office, you know, because everybody does study just PowerPoint and Word. Yeah. Right. So we have this guy here, which is quite an interesting one. And this one looks kind of tough, right? So let's see. We have x to the negative 1 plus y to the negative 1 all over x plus. Now at the end of the day, remember what the question asked us, yeah? Rewrite the following expressions using positive indices only. So we want positive indices only. Now at the end of the day, first of all, the bases are different. This base is x and this base is y. So you know, I can't really play with the indices here. Yeah. And I just going through the thought process. You know, this is how you guys should think about it, right? So I can't play with the indices here. I can't say this x gonna cross off with this x because that would have only been possible if it was x multiplied by y, but it's not. It's x plus y. I could also say, well, all right, I could split this up. If you all remember fractions, if I keep this as one denominator, remember, if it is that I have a common denominator, like let me just say I have 2 over 5 plus 1 over 5. That is 5 is the common denominator. So I could have 2 plus 1 all over 5. And right? So because if it is that I started off with 2 plus 1 all over 5, I could say, well, here now 5 is a common denominator. So I could split it up and say that is 2 over 5 plus 1 over 5. So you see, you had to work your arithmetic backwards in algebra sometimes. Yeah. So because I have this common denominator, I could say, well, all right, the common denominator is x plus y. And I could split it up. I could put x to the negative 1 and then plus y to the negative 1 all over the same x plus y denominator. You all understand how I got from here to here? Alright, Caitlin, I hope that if you have a problem you would say so, because I know you're quiet like a mouse, right? But at the end of the day, I still can't cross off nothing. It would have been easier if these two were being multiplied, because then the x's would have just been able to cancel off. But it can't. But the question asks for positive integers only. So, indices only. So let's get rid of these negative guys. So we know that x to the negative 1 is really 1 over x, and that being divided by x plus y. Yeah? And then plus 1 over y, and that being divided by x plus y. So at the end of the day, guess what? This here is pretty much it. I don't think I could do anything else with that. Can we do anything else with that? Well, what about this whole invert and multiply business? Remember, when it is you're dividing by a fraction, like a over b being divided by c over d, right? You actually take the denominator and multiply and invert it, d over c. Remember this?
Yes, sir.
Well, let me try that here and see. It's all about trying things. Because this is really x plus y over 1, and x plus y over 1. So I could say that I could invert and multiply 1 over x multiply by 1 over x plus y. Plus invert and multiply 1 over y multiply by, and if I have invert this, I'll get 1 over x plus y. So now I can multiply these guys out. So this one here, the numerators will multiply to just be 1, and the denominators can multiply to give me x multiplied by x plus y, and then plus same thing here, 1 all over y multiplied by x plus y. And can that be a thing further?
Yes.
How? Oh, yes? You say yes. How could I simplify that further? Multiply the brackets?
Yeah.
Alright, but no, I'm not going to multiply the brackets. You know why?
Yeah.
Because that's going to make things more complicated. I don't want complicated. I want simple. I want the simplest form. So I'm going to end up with x squared plus xy. That seems, you know. But I have something in common with these guys, right? What do I have in common? I have 1 over x plus y. That's what I have in common, right? So I didn't even really need to go to this stage, you know. I could have just say from this stage that this 1 over x plus y is being multiplied by both of them. If I pull out 1 over x plus y, and that's being multiplied by 1 over x plus 1 over y. How will you feel about this one? Are you confused? Scotia, you okay?
Yeah.
Yeah, Shizzy, you alright? Shizzy?
Yes, sir.
Alright, and Caitlin, you okay?
It's confused.
Okay, what part confused you? From here?
Notice what a this, but I failed to get to the one that I was looking
From this line over here?
to. Yeah.
Alright. So I'll just erase that, I'll just do it again. I'll just do it real quick just for the sake of Caitlin, because it's important. So you understand that if I have a fraction a over b all over c over d, that I take the denominator a over b and I invert it, right?
Yeah.
Right. Well, look at this denominator. This denominator is x plus y over 1, isn't it?
Yeah.
So if I invert that, I'll get 1 over x plus y. And?
Yeah.
Right. So what I'm doing is I'm just taking my numerators and I am inverting the denominator, because that is what you just do when you're dividing by a fraction. You invert and multiply. So this one now, I have the numerator 1 over x, and that's being multiplied by inverting the denominator 1 over x plus y. You understand that, Caitlin?
Yeah.
Okay. And then I have my plus. Same thing with this side. 1 over y is being multiplied by 1 all over x plus y. And I'm seeing that the 1 over x plus y is being multiplied by both of them. So I could pull out the 1 over x plus y, 1 over x plus y, and I could put in brackets there 1 over x plus 1 over y. Because we see in here that if I could take this and multiply it, and that'll give me this, plus taking this and multiplying it by that will give me this. You seeing it now, Caitlin?
Yeah.
Now you see how beautiful algebra is? And not only that, right? But I did not use any algebra to solve this. I used arithmetic to solve this. Which is why I just always be saying that the problem students have with algebra is not algebra, it's actually arithmetic. Right? So, Shazay, you doing alright?
Yes, sir.
Right. Now in this one here, positive indices only. This is interesting. Any ideas for this one?
I actually left it.
Sorry?
I said I actually left out that one.
Left out this one. Alright, there's no key. Yeah, it is quite a tricky one. And it does require some algebra. But what you're noticing here, you noticing anything? I mean, at the end of the day, and 10 is a multiple of 5,
Yeah.
and 4 is a multiple of 2.
Yes, sir.
So I could say, but at the end of the day, can't really have 5 to a power to give me 10, can I?
No.
No, because 10 is 5 multiplied by 2, eh?
Yeah.
Well, look, I have that 2 there. So I have 10 is 5 multiplied by 2 all to the power of n, eh?
Yeah.
And then I have minus 4. 4 is 2 times 2 all to the power of n, and
Yes, sir.
and that is all over 5 to the n minus 2 to the n. So I just kind of, you know, Scotia, you understand how I reached there today?
Yes, sir.
Caitlin, you okay? So now remember the laws of indices: n multiplied by this 1 and n multiplied by this 5, eh? So now I have 5 to the n multiplied by 2 to the n. Right? This is 10 to the n. Right? And that's minus n. This 2 times 2 is 2 squared. So that's 2 squared all to the power of n. All over 5 to the n minus 2 to the n. Something kind of interesting going on here. I find so. Looks quite familiar. So let's deal with this guy, because you know this n is being multiplied by that too. I'm studying if I should do that though. I wonder, and well, let me try it and see. Right? So that means that 5 to the n times 2 to the n minus 2 to the power of 2n all over 5 to the n minus 2 to the n. You notice I can't do anything with the denominator because it's a minus. If they were being multiplied, then alright, but they're being minused, so you know, can't do anything with it. What if I take this denominator and I pull out 2 to the n from it? Right? So if I had 2 to the n on the outside, I'll keep my denominator the same way. 5 to the n minus 2 to the n. Right? And you know what I want to do is not that I'm pulling out 2 to the n on the outside. No, I'm not doing that. I want to end up with 5 to the n minus 2 to the n. I want to end up with that up here, because I'm noticing that that is what I have down here. So what do I have to multiply here? I have to multiply 2 to the n, and that will multiply by that. But then this will have to be squared over here. So this will have to be 2 squared over here. Interesting. Because I'm trying to get these guys. If I could get 5 to the n and 2 to the n, then I could get these guys to cancel. If I could do that. If I could do that. So you guys seeing any way to do it? So maybe I shouldn't have multiplied out this. So you know what? I'm gonna erase this section. Because I have 5 to the n here. And I have 2 to the n here. So what if I said that if I rewrote this as 5 to the n times 2 to the n minus 2 to the n squared. Make sense?
Yes.
Because they're both the same thing, all over 5 to the n minus 2 to the n. Caitlin, you alright so far?
Yes.
So where's this 2 to the n squared? Well, 5 to the n times 2 to the n minus 2 to the n times 2 to the n. And 5 to the n minus 2 to the n. Make sense there?
Yes, sir.
And now we could see that I could pull out 5 to the n minus 2 to the n and have 2 to the n outside. Yeah? All over 5 to the n minus 2 to the n. So you see, if I take this 2 to the n multiplied by 5, I'll get this. And if this 2 to the n multiplied by that, I'll get this. Caitlin, you okay there? Yeah? You don't find this kind of cool? Yeah, it's fun, right? So now, guess what? These two could now cancel because this is being multiplied here. And these two are the same thing. Remember, since this is being multiplied, I could actually pull it out and say 2 to the n over 1 is being multiplied by 5 to the n minus 2 to the n, all over 5 to the n minus 2 to the n. So that is why we could cancel these two. That is why these two will cancel. And your answer is 2 to the n. Watch that nice piece of magic now. It's a nice question, huh? You all don't find that cool? Am I the only one that does get excited by questions like this?
Yeah.
But you don't find it's kind of like Sudoku or crossword or something? Scotia?
I don't like this.
You don't like those games? Or you don't like brain games?
This question is like people put them in trouble for getting answer.
Yeah.
But here now, I really would ask you guys to see. Did you all write this down? Right? I really would ask you guys to re-examine this question and look at the thought process, because I realized there's not much I could do. I can't cancel out anything because this is a minus here. If it was a multiply, then things could have canceled like crazy. But I can't cancel out anything. So I decided to split up the numbers because I noticed that 10 and 5 and 10 and 2 have things in common. So 5 times 2 to the n. 10 is 5 times 2. So that's 5 times 2 to the n. Yeah? And then I express 4 as 2 times 2 to the n. I leave my denominator alone. Okay? And now, using my laws of indices, I can actually split this up into 5 to the n times 2 to the n. Minus 2 squared to the n. Okay? But then, from 2 squared to the n, that is where I went wrong. And I bounced a wall. So I say, you know what, instead of 2 squared to the n, let me use 2n squared, because they're the same thing. Because the indices just being multiplied. So 2n squared ends up being 2 to the n times 2 to the n. And now I'm seeing a very dread similarity between the numerator and the denominator. Bunch of 5s and 2s. So hopefully I could start to group it. I pull 2 to the n out, distributive law, and I end up with numerator and denominator being the same thing. I love this question. This is a beautiful question. I really love laws of indices, Laws of indices fun. All of that boring. You can't see the question boring or the question hard. It's all of that boring. Bunch of boring. So I guess nobody got that one, right?
Yes.
But look at all of the cool stuff we're learning from the things that we get wrong. Yeah. Let's try number 43. Number 43 looks a little bit easier. I have 2m squared n all to the power of 3. And I guess in Shazay you would have made the same mistake here. Because remember that 2 is to the power of 1. Yeah? And this is being divided by m n cubed all squared multiplied by 4m squared all squared. So now I think we know what to do. It's just a matter of expanding those brackets. So this is 3 times 2 to the 1, which is 2 to the 3. And then this 3 multiplied by this 2 gives me m, 3 2s are 6. And then this 3 multiplied by this 1 gives me n cubed, all divided by, same thing here. This 2 multiplied by this 1 is m squared, n to the 2 times 3 is 6. And that's being multiplied by this 2 times this 4 to the 1, and so that is 4 squared, right? This 2 multiplying by this 1, and this 2 multiplying by that 2, m to the 4, right? I could get rid of this multiplication sign because everybody is being multiplied anyway, right? So I could say that 2 cubed, and let me write it here, 2 cubed m6 n3 is being divided by, right? Let me handle this 4, because 4 squared, what is 4? 4 is really 2 squared, and that 2 squared is being squared, and we know that 2 times 2, laws of indices, 2 to the 4. So 4 squared is really 2 to the power of 4. So I could put the 2 to the power of 4 over here, right? And that's my 4 squared. Now let me handle the m's. It's being multiplied, so that's 4 and 2, that is m to the 6. And then now I have n to the 6. Caitlin, you understand how I got there? Right. So now, well, of course, these m's gonna cancel, right? This will be 3 minus 1. So this will be 2 to the power of negative 1. So that is, remember, 3 minus 1. 2 all over 2 to the 3 divided by 2 to the 4 is 2 to the 3 minus 4, which is 2 to the negative 1. And then I have n to the 3 minus 6, n to the 3 minus 6, which is n to the negative 3. I don't want negative, did they say negative? Simplify, alright, this is a different question. Simplify the following expression. Alright. So, if I wanted to, I could just pull out negative 1. So I could say this is 2 to the 1, n to the 3, all to the power of negative 1. You see how dread your laws of indices is? Right? And if all of this is to the power of negative 1, then that means that that is 1 all over 2n cubed. How will I like this one?
I like it.
You don't like it, but you understand, though, Shazay?
Yes, sir.
And Scotia, did you understand?
Yeah.
You get this?
No.
What was the error? Any idea where the error was?
Oh, yeah.
Did you convert this 4 squared into a base of 2?
No. The same error is where that kind of.
Yeah, so I'll be careful with that. Caitlin, you doing okay in the corner there? Caitlin, I can start to call you Minnie. You know who's Minnie? Minnie Mouse, yes. You just can't remind me of Minnie Mouse. I can't call you Minnie, no? Okay. Fine, Caitlin. Just take all of my joy in life away, okay? Right. So with this one, number 44, right, we could see here that 5 x to the 5th y squared multiplied by 3 brackets x y cubed. The y is cubed there, not the x. But all of them are squared though. Right? And that is divided by 15x squared y. Scotia, I saw some good stuff from you for this one. Right? Huh? Right? So obviously we could expand out these brackets here. So I'll have 5x to the 5th y squared multiplied by 3. This will be x squared y 3 2s are 6 divided by 15x squared y. Is that 15x squared y? Yes. And what now we could multiply out these terms. So 5 times 3 is 15. X 5th times x squared is x to the 7. And y squared times y 6 is y 6 7 8 all over 15x squared y. And of course the 15s will cancel. This y will cancel with one of these, so I'll have y to the 7, right? And this x, 2 x's will cancel for one of these, so I'll have x to the 5th, y to the 7. That is your answer. So Scotia, did you make this mistake over here? Yeah. Shazay, how you did with it? Yeah, what's that?
I was so close to the answer.
Yeah. I'm pretty sure that you all would never make these mistakes again. Caitlin, are you getting these questions here correct, or are you making the same errors that the two of them making?
I made some errors, but I understand what I'm doing.
So you're understanding what we're doing here, right?
Yeah.
Right. So that's the hardest of the hardest questions are done. Did you guys have any idea how to approach these guys? Yeah, well, I think that you were on the right path from what I saw that you were doing, right? Let's look at this first one. Actually, you know what? Let's look at this second one here, because this second one is the easiest one. And when you see how to do that, you'll understand how to do the rest of them, right? So, this second one is 2 to the power of x is equal to 8. And you have to find x, so you have to solve for x, right? So what I'm going to do is I'm going to express 8 as a base of 2, right? So what is 8? 8 is really 2 times 2 is 4 times 2. 2 2s are 4, 2s are 8. So 8 is really 2 cubed, isn't it? So I could say now that 2x is equal to 2 cubed. And now that the bases are the same, that means that I could just equate x is equal to 3. That's your answer. Alright, is this how you did it, Scotia?
No. Yeah, that's the same exercise.
Well, that's curious. How do you do it?
I kind of multiply 2 until I get 8.
Can I multiply? You do what I do here?
Yeah.
And then you get this and you use this number.
Yeah.
Well, it's the same thing. It's the same thing. You just thought about it differently, right? Caitlin, how you did with this one? You did not get it, right? You understand what I did here, though?
Yeah.
All right. What about you, Shazzy?
I got it.
You got it. Nice. You saw these kind of questions before.
No, but it reminds me of the subject and formula questions. So I just use like the square root
Right.
and I get it.
So you didn't do it the way we did it.
Not really.
Right. What square root thing you do? I'm curious.
So it was 2 to the power x is equal to 8. So I did x equal to the square root of 8. Wait, what?
Mm-hmm. What is the square root of 8? Square root of 8 is not 3. And at the end of the day, this is not correct at all. What you just did there? No. You could only say that if it was x squared. Yeah? If you have a square here, well then, if it is that I had x squared, then I could say x is the square root of 8. You seeing that?
Yes, sir.
Right? Because you have a square. X squared, you have a square. So therefore, to get rid of a square, you find the square root. Right? If x cubed was equal to 8, to get rid of that cube, you would find the cube root. But guess what? We don't know what that is. So if you want, you could say that 2 is equal to the x root of 8. But guess what? X is still unknown. So that does not help us. You understand, Shazay?
Yes.
I'm still curious as to know how you get through. Alright. Let me see how 45 goes. Alright. Sorry, that's not x. That is 3 to the power of x is equal to 81. Now, I will express 81 in terms of 3 in order to get x. Right? So, what is 81? 81 is 9 times 9. Right? So, therefore, 3x, 81 is 9 squared. So 3x is equal to 9 squared, because 9 times 9 is 81. Okay? But now, I could say, well, alright, what is 9? I'm leaving the square on the outside there. What is 9? 9 is 3 squared. Yeah? So now I have 3x is equal to 3 squared, and in brackets there, 3 squared is 9, and then that being squared. So now I could use my laws of indices to say 3 to the x is equal, we'll just multiply these two to get 3 to the 4. Therefore, x equals 4. How you did with this one, Scotia? All right. I think you pretty much did it the same way. But did you write down this stuff?
Yeah.
All right. I hope you guys are writing down all this stuff, by the way. Now this one is a bit tricky. All right. Now we have x to the power of negative 2 is equal to 9. Any ideas? Well, if I want, I could say, using my laws of indices, x to the power of negative 2 is really 1 over x squared. Now I know what Shazay thinking, Shazay thinking, well, you can't just say x is equal to the negative 2 square root of 9? The negative square. But no, we don't have such a thing. But I do recognize, though, by my laws of indices, that 1 over x squared is equal to 9. You okay with that so far, Shazia and Caitlin?
Yes, sir.
Yeah.
But you know what? I could flip both sides now, right? I could flip both sides now. And tell me if you see this. If I flip over the x squared, so I flip x squared over 1. But then that is equal to, guess what? I'll have to flip the 9 too. So now I'll have 1 over 9. So you see the flipping thing that I did? It's kind of like magical, right? Did you guys know you could do that? Yeah? Didn't know that you could do that?
Yes, sir.
So, yeah, if you flip one, you flip the other, right? So therefore, x now squared is equal to 1 over 9. So x is equal to the square root of 1 over 9, which is 1/3. Right? So this is something in algebra that basically works, right? Like if I said a half is equal to 2 over 4, would you say this is a correct statement?
Yeah.
Well, now let's flip it. So 2 over 1 is equal to 4 over 2. Would you say this is a correct statement?
Yeah.
Kind of cool, right? So you see what going on here is this is basic arithmetic that we are using in algebra. I just keep saying the problem with algebra is not algebra, it's actually arithmetic. I just keep saying. I just say it over and over and over. Now I actually wanted to talk about a topic here. Maybe we'll have to go straight to 8 o'clock tonight. But the topic has very much to do with these guys. Okay? Because we have x cubed is equal to negative 125. So we know that x will be the cube root of negative 125. Can I have a cube root of a negative number?
I don't see why not.
Right? Can I have a square root of a negative number?
Yeah.
Right. This one is no. You cannot have a square root of a negative number. Never. That is mathematically impossible. And we'll talk about that just now. We will talk about why. But this one is good. And that's we'll talk about why just now. We will talk about why. But you cannot have the square root. The square root of a negative number does not exist. And we will see why just now. So the cube root of 125, I believe, is just negative 25. Okay, so that's the answer. 25, is it? No. 5 times 5 times 5. Right, sorry, my bad. I'm probably just tired. Negative 5 is the answer. Shazay, you okay with that?
Yeah.
You just don't know about the negative. Why you can't have a negative square root, but you can have a negative cube root.
Yeah.
Yeah. Okay. We will see. Right? It's actually quite elementary. It's quite simple when we see, right? So 4x is equal to 32. Can 32 be expressed 4 4s are 16? Okay. 16 times 4 is 64. So 32 cannot be expressed in terms of 4. Can 32 be expressed in terms of 2? Yes. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So 32 is 2 to the power of 5. Yeah? That's 32. And 4 is 2 squared, all to the power of x. So now, you know, I can multiply these indices here to get 2 to the power of 2x is equal to 2 to the power of 5. And because the bases are the same, I could therefore say that 2x is equal to 5, and therefore x is 5 and 2. How are you feeling about that? Scotia, you alright? 4 to the power of 2.5.
Yeah.
That's interesting. Yeah, that's correct. Because 5 divided by 2 is 2.5. Yeah, which is 2.5. Right? So 4 to the power of 2.5 was what you got.
Yeah.
How did you get it?
Well, I knew that 4.4 is 16.
Wow, you use a dread piece of reasoning there, girl.
So I just knew it was kind of be half of that.
Yeah, but that was still a guesstimation though, huh?
Yeah.
Yeah, but do you understand what I did? Right? And did it seem simple?
Yeah.
Right? So now I have this here. 9 times 3 to the power of x minus 1. What the hell is that? Is equal to 1 over 27. Well, you know what? Let me throw across the 9 now. So 3 to the power of x minus 1 is equal to 1 over 27. It's being multiplied by 9, so I have to divide by 9 over here. Right? And just to make it less complicated, I'll put divided by 9 over here. Because we threw across this 9, and it's multiplied. Right? Maybe we didn't have to, you know. No, we didn't have to throw across the 9. No. Look. 9 is 3 squared, and multiply by 3 to the x minus 1, and that is 1 over 27. So therefore, what do I have? When you multiply, you add your indices. So that is 3 to the power of 2 plus x minus 1 is 1 over 27. So 2 minus 1 is positive 1. So that's 3 to the power of x plus 1 is 1 over 27. Right? Can 27 be expressed in terms of 3? 3 3s are 9, 3s are 27, right? So 3 to the power of x plus 1 is equal to 1 all over 3 cubed. The 3 3s are 9, 3s are 27. Right? I could use my laws of indices to say that 3 to the power of x plus 1 is equal to 3 to the power of negative 3. Right? I hope I didn't lose you, Caitlin, with that one. Therefore, because these bases are the same, I could say x plus 1 is equal to negative 3. Therefore, x is equal to negative 3 minus 1. X is equal to negative 4. How do you feel about that one? Scotia? My biggest concern is if you understand what you're doing.
But, yeah, I do that.
But what? You was going to ask a question? Okay. Now, you could have thrown across the 9, eh? You could have thrown across the 9 and do more math something on that side, and you would have still end up with the same negative 4. Shazay, you okay with this?
Yes, sir, it's right.
Oh, okay, sorry. Let me know when you're done right, I should say. Caitlin, how you doing?
Okay.
You understand all of this stuff? It sounds like you're not okay, though.
I understand.
Should say you're done right?
Yes, sir.
I tell you to tell me when you're done. Okay, so out of this 30, I know I'll get 1 or 2 wrong out of the first 30. But out of this 20 over here, right, from 31 to 50, there's 20 questions over here. How much of these questions will I get wrong out of 20? A lot?
Yeah.
Yeah.
Now, I wanted to do these questions with you guys. And these questions here are really, really important. But we're running out of time, so we'll do this next class. Alright? And I actually have a hell of an assignment there for you. So we'll look at the assignment just now. But there is one topic that I wanted to do with you all. And that is roots. Specifically square roots. Okay. So let's just take a look at this topic nice and quick. So we could remember that if I have 5 squared, that is 5 multiplied by itself, which is 25. So therefore, 5 squared is equal to 25. And 5 is equal to the square root of 25. Okay? Everybody okay with this?
Yes, sir.
Alright. Let me ask you another question. What is the square root of 25? It goes deeper. The rabbit hole goes deeper. What does square root mean? Remember we were saying the square root sign is like a question, right? Remember we were saying that? What is the question?
So,
25, eh?
yeah.
What number multiplied by itself, right? Which number times itself equals 25? That is the question. There are 2 possibilities. I could have 5 multiplied by 5 to give me 25, but I could also have negative 5 multiplied by negative 5 equals 25. And
Yes, sir.
so that means that the square root of 25 is not just 5. It could also be negative 5. So for all square roots, the answer is positive or negative. So if somebody asks you, and from now on, make sure you remember, if somebody asks you what is the square root of 25, The answer is plus or minus 5. Everybody understand this?
Yes.
Caitlin, you alright?
Yeah.
But which number times itself? And so that means that if I have a positive number, I'll have to multiply it by itself. Therefore, a positive times a positive gives me a positive. If I have a negative number, then a negative times a negative is also positive. Because the two numbers you are multiplying has to be the same. Because a square root is a number multiplied by itself. So you can never have a number multiplying by itself and giving you a negative answer. You could never have it. The only way that you're gonna get negative 25 is if I had negative 5 multiplied by 5. That will give me negative 25. But this is not a square root situation because these two numbers are different. This is not a number multiplied by itself. So that is why. This is why you can never have the square root of a negative number. Because how do you get a negative number? The only way to get a negative number is to multiply a negative by a positive. But guess what? That is not a number by itself. That is not a square root. The only way you'll have a square root is multiplying a number by itself. So if that number is negative, it'll be multiplied by a negative to give you a positive. If a number is positive, it's multiplied by itself to give you a positive. So everybody understand why you could never have a square root of a negative number? Right.
Yes.
So note, you cannot ever have the square root of a negative number. Never. So if you was doing a question and that question give you an answer of a square root of negative x, for example, you are supposed to say that this does not exist and therefore there is no answer to this question. Does everybody understand?
Yes.
But I can have, however, and I hope all you're writing on these notes, right?
Okay.
Shizzy, you get all these notes so far?
I didn't get from the notes.
You didn't get from this note?
The notes.
You mean you didn't get none of this?
One part of the notes you cannot say that. I didn't get that.
Well, get it now, quick. Crap, I just know I lost it. Where did it go? Where did it go? Okay. Tell me when you're done, Shazia. Waiting on you.
I got it.
However, if I have -5 times -5 times -5, yeah? Alright, let me not use -5 because that number too big. How about -2 times -2 times -2? Nth is the same number being multiplied by itself, nth? So -2 times -2 is +4 times -2. And that is equal to -6. No, sorry, hear me, -6. 4 times 2 is 8. You see how nobody are correct, man? Or they're sleeping. Right? So -8. So you see here that in this case, I can have -2 cubed is equal to -8. Therefore, -2 is the cube root of -8. So, yes, we can have the cube root of a negative number. Caitlin, you understand this?
Yeah.
Shazay, you okay with this?
Yes, sir.
So you all see why you could have the cube root of a negative number, but you could never have the square root of a negative number. So summary. If you have an even root, so whether it's 2, the 2 root, or the 4 root, or the 6 root, or the 8 root, once it's an even root, then you could only have a positive number. But if you have an odd root, like 3 or 5 or 7, then you can have a negative inside of here, or you can have a positive inside of here. So everybody understands this?
Yes, sir.
No. I didn't think that these questions were going to take so long to do, but they took most of the class. I wanted to do these questions with you guys today, and these questions are more indices questions, but we wouldn't get a chance to do it, so we'll do it next class. Right? You had a little thing on square roots. Let me see, is there anything else I have to tell you about square roots? Remember, a square root could come from either a positive or a negative number. So the root of 25 is plus or minus 5. Right? But I can't have a negative number inside of a square root. One other thing. Right? One other thing about square roots, and this is an important one. Remember how we have the law? Recall the law that, where's the law again, boy? A to the m all to the power of n is equal to a to the m times n. Remember this law? So if I had x, y, the square root of x, y, is this not x, y, all to the power of a half? And remember that half is being multiplied by that 1, and the half is being multiplied by this 1. So therefore I will get x to the half times y to the half, which is the square root of x times the square root of y. Make sense?
Yes, sir.
Caitlin, you okay with this?
Yeah.
Shazay, you alright?
Yes, sir.
Therefore, the rule is, if I have the square root of a product being multiplied, it doesn't matter, it could be x, y, z, p, q, r, s. I could actually split it up like this. Just no, sorry, not like that, but like this. You all understand why?
Yes, sir.
Okay, I think that is it. So we just did a little bit on square roots, and let me just show you guys the assignment. Now, I'm gonna show you the assignment, but I know that you all have a lot of stuff on your plate. It is Tuesday, however, so Tuesday to Saturday you do have a lot of time to do the assignment. Now, the assignment is real question, and at the end of the day, this is an introduction to algebra that we do. We aren't really getting to any hardcore algebra yet, right? And I've taken my time with this introduction because I want to show you guys a couple of things. Number one, that all of your algebra problems actually come from arithmetic. And this whole introduction to algebra is really supposed to just relate the algebra to the arithmetic. That is what this entire introduction to algebra was all about. So at the end of the day, I have some questions here. I really want to focus on laws of indices. Do not let your laws of indices escape you. Make sure you know your laws of indices. And I promise you see some of them questions that we do with the 10 to the n minus 4 to the n all over 5 to the n minus 2 to the n. You'll never get that in CSEC, don't worry. Yeah, you see plenty of them questions on the side, you'll never get it in CSEC. You might get some of the algebra ones though, like 2 to the m squared n. You'll get some of the more algebra ones. But if you do get it in CSEC, it's not going to be as hard as the ones that I'm giving. Right? It wouldn't be as hard as that at all. However, know your laws of indices, because laws of indices, if you look at it, you see how these things were derived. We saw how these things were proven. It's basic arithmetic that we use to prove these things. Your laws of indices, it came from arithmetic. Remember, this is the second time we're doing laws of indices. The first time we did it with numbers, and this time we're doing it with x. Yeah? So at the end of the day, I'm showing you that your laws of indices is basic introduction to algebra. You're going to need to know your laws of indices when you're doing coordinate geometry, when you're doing quadratic equations, when you're doing simultaneous equations. Your laws of indices will help you. Any situation where you have an algebraic function and you have to simplify it, is your laws of indices that are going to help you to simplify. So I'm really spending some time on the laws of indices, right? And I've given you all a lot of questions. Now, this next assignment has a lot of questions, and I really want you guys to do all. But the bright side is that you're going to have all of the answers. So you're going to be able to see your answers, right? Now, let me just show you it and tell me if you could accomplish this for Saturday, right? So watch. There's quite a lot. Everybody seeing this?
Yes, sir.
Classwork. We just did laws of indices there, intro to algebra. We just did laws of indices, and this is the next assignment that's due for Saturday, October 17th. And is some more laws of indices and square roots, right? So take a look at this. You all seeing this, right?
Yeah.
Now this first page, these are not questions. This is just a summary of all of your laws of indices. And you actually have the names for them. Like this one is the quotient rule. The product rule, you add your indices. The quotient rule, you subtract your indices. You know, you have the zero exponent rule, you have the power rule, you have the expanded power rule, you have negative exponent rules. So this first page is just a summary of your laws of indices, a little bit of a reminder. Then we get into the questions. So this first set of questions here, we have 38 questions. Right? But you can see they're pretty easy. You could probably do one of these in a couple of seconds. And then some of them might seem a little bit tough. But, you know, most of them, you could probably finish this entire thing in 15 minutes, honestly. And then you have all of the answers over here. Alright? Then we have some very simple, again, simple because I just want you guys to really practice getting to know your laws of indices. So if you look at it, these guys here are really, really simple. You have some of them that looking a little more complex, but they're certainly not as complex as what we were just seeing. So everybody should be able to do this and this simple little questions. Right? And they're getting a little more complex coming down here, but they're still generally very easy. We aren't dealing with, it didn't have none of the bracket ones yet. And look, so there's 30 questions in these 2 pages here, but these 30 questions you might probably knock down in another 15 minutes because it's just real easy, simple things like this, you know? And so these 30 questions, you have the answers for them over here, so you could check and see your answer. Right. And then I have these questions here, and these questions, laws of indices, but these are more, I should not, this laws of indices should not be here. This is supposed to be roots, right? So these here are the questions that is just to help you to practice your square roots and your knowledge of square roots. So these questions here, you have to solve each equation. So you have B here, you have to solve what is B. B is equal to what? Yeah. In this case, I think 3 is a 9 and 1 is 10. B, and for this first one, B will be 10. Yeah. So this here, they're really, really simple questions. Right? But they are practicing the knowledge of the square roots and roots in terms of indices. Right? And these are all of the answers here. And that is it. So it's really 3 exercises in one. You have this 20 questions here on square roots. You have this 30 questions here. So that's 50 so far. But simple indices, and then you have another 40, so that is 90 indices questions that you should be able to cut down in about an hour if you know your stuff. So do you all think that you all can hand me that entire assignment for Saturday, or do you think it's too much?
Yeah.
I have one here. Caitlin? Caitlin's like, oh gosh, no, my head hurting, my teeth hurting. Well, the questions there are overall not as hard as the questions we were seeing today. Yeah, so the questions, they are not as hard as the questions that we were seeing today. You should be able to knock out all of them 90 questions in about an hour, maybe an hour and a half at the most. And at the end of the day, by the time you finish this, and so this Saturday we will just be doing all laws of indices questions. And if you could finish this assignment, then on Saturday I will leave you with no homework and you can relax for the weekend. I'll give you that reward, right? So see if you finish these questions, and we almost finished the introduction to algebra. Once we finish laws of indices, we just have one more topic to do before we finish the introduction to algebra, and then we can move on to other things, right? So anybody have any questions about today? If nobody have any questions, I'll see you all on Saturday.
Nice.
Bye.